Okay, so this is the last class for exercise 8.4. Okay, these questions that were written on the board we're going to do. So let us start with question number 4, exercise 8.4. Okay, page 202. Open your textbook there. Okay, there it says choose the correct options there and justify your choice. So let us start with the number 1. There it says 9 sec square a minus 9 10 square a equal to what? We have to find this. So that will be equal to here. Okay, or you can just write here once more. So 9 sec square a minus 9 10 square a. We can rewrite it in this form. 9 is the common factor in both terms, so outside the bracket into sec square a minus 9 has been taken out, so here 10 square a. We can write in this form, right? So here 9 into, by formula we know that sec square a minus 10 square a is equal to 1, so that our answer is now 9. So the options that are given are B is the one that matches, so the answer is B, which is given as choice number B, which is given as 9. So that is the answer. Let's do the number 2. We have to find out here sec a plus 10a. Okay, sec a plus 10a into, bracket means into, 1 minus sin a. So we have to find out what value is this. So here let's change all these terms into the form of sine and cos by formula. We know sec a can be changed to 1 by cos a, plus 10a can be written as sin a by cos a, and this one is the same, and sin a is fine. Everything is now in sine and cos. That way we can get some answer, I think. So here the LCM of these two denominator is cos a, right? Cos a into 1 is cos a, so 1 ones are 1 plus cos a into 1 is cos a, 1 into sin a is sin a. So this is the portion for this, right, into 1 minus sin a. If we look at this carefully, we see that this is in the form of numerator a plus b into a minus b. So there will be a square minus b square formula we can apply, divided by these two, I mean a plus b into a minus b, a square minus b square by cos a, right? Then 1 square is simply 1, so 1 minus sine square a, we know formula is cos square a, divided by, down here is cos a, so we can just write it like that. Then here cos a to the power 1 gone, and 2 minus 1 power is still 1 is left, so that is left with simply cos a. So the right option there that matches that one there, choice number 2 is here. This is number 3, sorry, this is number 3. We have by mistake done number 3 first, so that is here D, choice D. So the choice D match this one, which is cos a. Okay, so that is our answer for number 2. Now let's go to number 2, because we missed that out, sorry. Go back to 2 and say it's 1 plus 10 theta plus sec theta. So here 1 plus 10 theta plus sec theta into 1 plus cot theta minus cosec theta. 1 plus cot theta minus cosec theta. Bracket is closed here. So this is equal to what? We are going to have to find out this one. Like we do it for number 3, let us change everything to sine and cos. Tan theta can be changed to sine theta by cos theta, plus sec theta can be changed to 1 by cos theta, right? Now, having done that, let us do the similar thing with the next one. 1 plus cos theta can be written as cos theta by sine theta, minus cosec theta can be written as 1 by sine theta. Okay, let's just do carefully. It's just a matter of simplifying it carefully. So here cos theta LCM is cos theta. Just like the LCM of 2 and 2 is 2. So LCM of cos theta and cos theta is cos theta, right? By the same logic. So here 1 is there down, so cos theta into 1. That one we can just multiply, plus cos theta into 1 is cos theta, right? 1 into sine theta is sine theta. Likewise, this is same here, so into 1, 1 ones are 1. Then we can write here similarly, sine theta is the LCM of sine theta and sine theta. So sine theta into 1, sine theta, plus sine theta is there, so 1 into cos theta, minus sine theta is there, so 1 into 1 is 1. So we get that format, right? Now look at this one. If we observe this carefully, we can change this to this format. Here, see, this portion cos theta plus sine theta, we can let us separate it as one term. So second bracket plus 1. This one here, this one. Likewise, let us do it here on the numerator. So let us change everything into one line now, if you want. So here, just like cos theta plus sine theta, here also, second place, let us bring it to the first place. Here, cos theta, then no sign here means again plus sine theta minus 1. So let us put this one, these two as together. These two here, cos theta and sine theta, and minus 1. So we have used up the first bracket, so that way. Why we're doing this is so that, okay, this one you can write down, cos theta into sine theta. That way the advantage is here, these two is same now. So it will be like A plus B into A minus B. So we'll get that format, A square, that is cos theta plus sine theta whole square, minus B square, so 1 square, divided by, this one will remain same, cos theta into sine theta. Okay, now let us solve, continue. So from here we're coming, that will be equal to A plus B whole square formula, let us apply. Then we'll be getting here A square plus B square plus 2 into A into B. This portion, A plus B whole square, A square plus B square plus 2 into A into B. Minus here, 1 square can be simply written as 1, divided by down there is cos theta into sine theta, right? Now here, these two, if you were to take together, cos square theta plus sine square theta is nothing but 1. Up to here is 1 plus 2 cos theta into sine theta, the same thing here, minus 1 by cos theta into sine theta, right? Then here, sine in front is not there, means plus 1, here minus 1, 0. So we're left with here 2 cos theta into sine theta by cos theta into sine theta. So this portion cancels, leaving you behind 2. So the answer choice that match this answer 2, if you look there, is C. So our answer here is C, which is 2, right? So that is 1, 2, 3 done. One more there, 4. So let us go to the number 4. Number 4 is, question number 4, subheading 4. 1 plus tan square A. 1 plus tan square A by 1 plus cos square A equal to what? We have to find out which answer choice it match. So let us change everything into sine and cos. That is one best way of simplifying it. Tan A is sine A by cos A. So tan square A will be sine square A by cos square A. By the same logic, here 1 plus cot A is cos A by sine A. So by logic, we know cot square A will be cos square A by sine square A. Okay, then here, long line. Then we can do like this. Numerator here, the LCM is cos square A. So cos square A into 1 will be cos square A plus here sine square A by, down here the LCM is sine square A, right? Sine square A into 1 will be sine square A plus here cos square A. Okay, so here now, long line, formula cos square A plus sine square A is 1 by here cos square A, and then sine square A plus cos square A is again 1 formula. We know cos square A plus sine square A or sine square A plus cos square A is the same formula. So 1 divided by down here is sine square A. So if we change into this form, 1 by cos square A, keeping it same, changing this long line divided by into multiplication, down here sine square A will go up and numerator 1 will come down. So we're going to get equal to sine square A by cos square A into 1 is cos square A. Now sine A by cos A is tan A. So sine square A by cos square A will be tan square A. So our answer choice that match this one, your answer is found in tan square D. So D is the right answer choice because there is mentioning the answer choices. Tan square A, exactly the one we got it. So that completes this question 4. Okay, so we're done with 4. Let us now go to the next question. And the next question is examples there. So let us do that. Example 13, let us go there. Example 13. This you'll find on textbook page 200. Okay. Express the ratios cos A, tan A. Okay, let us start with the first one. Cos A, the first one. In terms of cos A, okay, and the next one, tan A and sec A. These three you have to find out. In terms of sine A. So we have to express all this answer in sine A form. So this is number 13. So let's start the first one. Doing with the first one, we can start with a very common one. We know cos square A plus, like this also again, sine square A equal to 1. Very common formula for us now. We need to find this cos A, so let's just take this term containing cos square A, which is similar, not exact but similar. 1, then shift this one, become minus sine square A, right? But we have to find cos A, not cos square. So remove the square, and we know root will come this side, 1 minus sine square A. So cos A is expressed in terms of sine A, see? So this is our answer, right? Then number 2, let us see there, tan A. So we know that tan square A equal to sec. Okay, we can express this one as also in the form of sec square. This also will come out, sec square A minus 1, let us say. So that will be equal to tan square A equal to 1 by cos square A minus 1. Like this also we can go. So here now, 1 minus cos square A by cos square A. Okay. So here, that implies tan square A will be equal to 1 minus cos square A when you multiply, divided by cos square A. Okay, so we can do that and then write here 1 minus cos square A. Okay, so this is sin A, 1 minus sin square A. Okay, so this one, yes, so here we have to change everything in terms of sign. So let us do that. 1 minus cos square A is equal to tan square A equal to here 1 minus cos square A we know is sin square A formula by cos square A. Like this also we can do. We're going a longer way actually, but that's fine. Now if you do that, then you write here, that implies tan A will be root over sin square A by cos square A, right? Then you can write here, sin square A can come out of the root as sin A by cos A. Okay, then everything has to be expressed in terms of sign. So this is fine, sin A. And we know cos A we have found out to be root over 1 minus sin square. So every value of tan A has been expressed in the form of sin. See, well, sin A by 1 minus sin square is the answer. And the third one here, let us go and see sec A. So number 3, subheading 3. Sec A is equal to 1 by cos A we can write directly. And we just did in number 1, cos A is root over 1 minus sin square A. So that is the answer for everything expressed in terms of sin A. See here. So that is example 13 is done. Let us go to 14. So example 14. So here example 14. Prove that. So let us take out the left hand side, which looks more complicated. Sec A into 1 minus sin A into sec A plus tan A. We have to prove this is equal to 1. Okay, 1. Right hand side is 1. So let's try to change everything into sin and cos. Sec A is 1 by cos A. 1 minus sin A is fine therefore, because we are intending to change all of this into sin and cos. So this is fine. Into here 1 by cos A for sec A, and tan A, one formula is there, we know, sin A by cos A. So everything is now in terms of sin and cos only. This way most of the time it's simpler. Okay, so let us do this. 1 into 1 minus sin A is 1 minus sin A by cos A, this portion. Then here LCM is cos A, as you can clearly see. So into 1 ones are 1 plus here sin A. So now we got this one in the form of A minus B into A plus B, which is very common formula, A square minus B square by cos A into cos A is cos square A. And we know 1 square means simply 1. So 1 minus sin square A formula we know is cos square A, by down here is cos square A. So these two cancel will give you, everything cancel means 1 left, which is exactly equal to the right hand side. Right? Okay, example 13, 14, then 15, the last one, last second, 15. Let us look into the question, page 201. Prove that, so let us take out the left hand side again, which looks more complicated. Cot A minus cos A by cot A plus cos A is equal to cosec A minus 1 by cosec A plus 1. So let's do this slowly. change everything into sine and cos, then we get cos A is cos A by sine A formula, we are using formula, minus cos A is fine. By this one also similarly, cos A by sine A plus this cos A, right? Now if we observe this carefully now, we see a common factor. So let us take out that one. Long line and equal sign first. Here cos A means this, we can take out of the bracket as common factor. Into cos A into 1 is cos A, by this is denominator sine A, minus cos A into 1 is cos A. I hope you're getting. Similarly here cos A is common, so let us take it out, cos A into 1 by sine A plus 1, cos A into 1, cos A. So this cos A and cos A can cancel, so you are left with 1 by sine A, formula 1 is there, cosec A minus 1, 1 by sine A is cosec A plus here 1, which is I think exactly equal to your right hand side there, you see. Yes, so here last question 16. This will conclude all the numericals in exercise 8.4, including the example. So if you follow the videos on any chapter in math science also, video 1, 2, 3, 4 till the end, you would have realized that every numerical in the exercise as well as in the examples are done, okay? And if you follow it by writing yourself, you'll get it very thoroughly, and it will make it so easy for you, okay? So here, once you are through example 16, page 201, you have the proof. Let us take out the left hand side. Is equal to sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1 is equal to 1 by sec theta minus tan theta. Let us do one thing, dividing by, okay, dividing both numerator as well as, okay, numerator, both numerator as well as denominator by cos theta, let us say. Then what will you get? Let's do one by one. That will give you equal to, left hand side equal to sine theta by cos theta is tan theta minus this cos theta, therefore is divided by this cos theta. Everything should be divided by cos theta, that's the meaning. Get 1, then here plus 1 by cos theta, we know sec theta. Everything is same, sine, cos, so same thing here, tan theta. Divide this cos theta by cos theta, then 1, so plus 1. 1 by cos theta, then sec theta. We are dividing both the numerator by sine theta. So every term up and down will get divided by sine theta, and we get this term. I hope you're getting it. Now let us do this. They are saying this one, prove this one using proof. Their question is saying proof by using the identity, means the formula. We have to use this identity. Identity, sec squared theta equal to 1 plus tan squared theta. We know this formula, then we have to use only this formula. So here, for that, let us do here sec theta, this one, and then here no sign means plus tan theta. Let us put it together, and here minus 1. Likewise, this one too, we just keep it for the time being, don't touch. Same thing. So look here, this one brought front, this one got second, and this one third. Is the same, we didn't change the sign, right? So next step is, here you see, let's put here, and then this one, sec theta plus tan theta minus 1 can be replaced by sec squared theta minus tan squared theta. See here, we are asked to use only this formula. So this formula means we can change in another form to use it also. This one brought minus to the left side and minus tan square theta and 1. See, we're using this, which is what the question is asking us. We're just using that in the new format. So that is 1 is equal to sec square theta minus tan square theta. So in place of 1, we're putting that. Okay, by down here, we just write the same thing. Tan theta plus 1 minus sec theta. Okay, there is no test for this portion. Okay, you just have to write along with it and understand it well. So next step, that will be equal to, let's say, long line. And then how about this? Here sec theta plus tan theta, just give it same for the time being, and then minus here a square minus b square, we can change it into a plus b into a minus b. So this one, a square minus b square equal to a plus b into a minus b. By down here, we can just write the same. For now, tan theta plus 1 minus sec theta. If you like, you can put in bracket, otherwise also okay. Now look at the numerator, something interesting will come out. Look here, sec theta plus tan theta, and these two are same, sec theta plus tan theta. So let us take that out as a common factor. Sec theta plus tan theta is found in both these terms, this one and this term. So let's just put like this, and you have taken out this out of the bracket. So sec theta plus tan theta into 1 is this one. Next is followed by a minus sign, so put it. Then sec theta plus tan theta has been taken out of the bracket as a common factor. So the other factor is bracket sec theta minus tan theta. I hope you got it. Then by here too, we can just write the same thing, tan theta plus 1 minus sec theta. Okay. Now look at this one. Here sec theta plus tan theta, that's fine. And then how 1 is okay. How do you remove this in inner bracket? When you multiply outside, sign with the inside. So minus into plus is minus sec theta. Minus into minus is plus tan theta. That's how we remove the inner bracket. And now there is no more first bracket. By here now you compare this one with this one. It's same. See here, 1, no sign means plus 1. So this plus 1 can go front. Here, see. Then minus sec theta is also here. So minus sec theta you can put in second place. No sign here, so plus tan theta. And it becomes exactly the same with the numerator factor here. This can be arranged as 1 and minus sec theta plus tan theta. Then it becomes exactly the same as this one to cancel out, right? So we're left with sec theta plus tan theta. So let us do that. We're coming to the last few steps, 2 steps I think. So how do you get? Right side is 1 by sec theta minus tan theta. So we are having only sec theta plus tan theta. So we need there on the right side, in the denominator, we need sec theta minus tan theta. Write that. Then whatever you wrote here, we have to put it here, sec theta minus tan theta. That way it becomes 1, like 5 is divided by 5. So these two cancel. If we won't cancel because we need it, but suppose you cancel, it's still 1. So we are multiplying by 1 only. So here now, so a plus b into a minus b, we can get it as a square minus b square by this one here, sec theta minus tan theta. Okay. Then here, by formula we know sec square theta minus tan square theta equal to 1. So we can just write 1. By down here is sec theta minus tan theta, which is exactly equal to the right hand side. So this concludes the last question for this exercise 8.4, including all the examples. Okay.